Welcome to your second flip video. This is 2.0b exponent operations. Rule 1, multiplying exponents. Make sure you have this next to the red line on the left side of your paper. When we multiply exponents, we're thinking of x cubed, this is just an example, times x to the fourth. Now, if you're going to write that in expanded form, you already know that you would write x 3 times x times x. And then you're still multiplying by this x to the fourth. So we actually add 4 more x's when we're multiplying. Now you see that there are 1, 2, 3, 4, 5, 6, 7 x's. So what we're proving here is that if we have x to the third times x to the fourth, we actually can say x to the 3 plus 4 equals x to the 7th. So now we've simplified the expression, and we didn't have to write an expanded form like we did here. So the rule is that if you have two of the same bases with different exponents or the same exponents that are being multiplied together, you can add them, add the exponents, and you eventually get x to the 7th power. So this is the simplifying rule for multiplying exponents. Here's an example of multiplying exponents. Now, you see here that we have two different bases. The first step underneath this to simplify the expression is that we combine the bases that are the same. So this is all multiplication. You already know that. And I'm going to rewrite this underneath. K to the third times k to the fourth. I'm going to put that in parentheses because I want those two together, since I know I can combine those exponents. And then, since the parentheses are next to each other, we're still just multiplying. This is g squared times g to the fifth. Now, according to the rule of multiplying exponents, we now can do 3 plus 4 to know what the new exponent of k is. So k, now 3 plus 4 is 7. G squared times g to the fifth is the same as g to the 2 plus 5. So our answer here, is g to the 7th as well. Now we have simplified the expression. Our next rule goes along with dividing exponents. And if you're thinking in your brain, okay, multiplication of exponents, I add the two exponents. I wonder what I do when I divide the two exponents. If you're starting to think of the opposite operation, you are on the right track. So, x to the fourth divided by x to the third. So, our goal here is to simplify. So the directions will say simplify this expression. First thing I'm going to do is write this in expanded form. So the numerator has x times x times x times x over x times x times x. So all I did there was just expanded this so that I have the whole thing written together. Now, you know that if two things are the same, the numerator and the denominator, they can cancel each other out. So these two x's cancel out, these two x's cancel out, these two x's cancel out, and all we're left with is x. Okay? So that means the rule is that if we have x to the fourth divided by x to the third, this is the same as x to the 4 minus 3 power. 4 minus 3 is x to the first, And you know from our rules from last video that anything to the first power is just itself. So what we just proved is that when we're dividing exponents with the same base, we can just subtract. So 4 minus 3 is 1. We simplify even further and we get x. Okay, now let's go ahead and look at example here. Notice that the z and the z are not right on top of each other. The m and the m are not right on top of each other. This is mixed up. Our job today is to simplify this expression. So the first thing we're going to do is split it up into z's and m's. So underneath you would write z to the 7th over the other z that's in the denominator is z to the 2nd. I'm going to go ahead and put this in parentheses since I want them to be together now. And then I'm multiplying m to the 3rd, which is in the numerator, over m to the 2nd. Now, you know that z to the 7th and z to the 2nd have the same base, and our rule told us that if we have the same base, we can subtract the exponents when we're trying to divide two exponents. So, z to the 7th and z to the 2nd, 7 minus 2 is 5, so this becomes z to the 5th, m to the 3rd, and m to the 2nd. We know that since our bases are the same, we are dividing these two exponents. We can do 3 minus 2. 3 minus 2 is 1. So now my new exponent is 1. Now just like last time, remember we're not in simplest terms if we have an exponent of 1. So we now have z to the 5th times m. And that's it. Okay, rule 3, we have some negative exponents today. So let's look at this. If we have, let's say, x to the negative 3rd, the way we write this is just with the x to the 3rd in the denominator. So notice when I did that, I got rid of the negative exponent. So now I have 1 over x to the 3rd. This is something you're really going to need to know for high school math. For now, just know that when you see a negative exponent, it throws the exponent and the base into the denominator. Let's check out an example of this negative exponent thing. So if I give you 4 to the negative 3rd power, you would know, okay, to get rid of that negative exponent, I have to throw it into the denominator. And then to solve, we know we have 4 times 4 times 4 in the denominator. 4 times 4 is 16. 16 times 4 is 64. So my answer is 1/64. And that is the final answer.